A warm welcome to one and all. Hear this lecture. At the end of this lecture, the students will be able to understand many switching devices from thyristor family to transistor family. During this lecture, the following topic will be discussed: introduction about power electronics, fundamental concept in power converter, classification of power semiconductor devices, BJT, the features based on its switching characteristics. In general, power electronics is the study of electronic circuit used to convert and control the flow of electrical power. Power conversion at the time of power processing deals with process of converting electrical power from one form to another. The power electronic circuit performing power conversion are referred to as power converters. Semiconductor devices are used as switches for power conversion. This is the general block diagram representation of power conversion systems. A function of power converter at the middle is to control the energy flow between source and load. Next, we will discuss about types of power converter based on converting electrical energy from one level of voltage, current and frequency to another level using semiconducting devices. Control rectifiers which convert a fixed AC power to variable DC power. The variable DC power is obtained by controlling the firing angle of semiconductor devices. Inverters which convert fixed DC power to variable AC power. Here variable AC power is obtained by controlling the duty cycle of semiconducting devices. The DC choppers convert a fixed DC power to variable DC power. Here the variable DC power is obtained by controlling the duty cycle of semiconducting devices. The AC choppers convert a fixed AC power to variable AC power at fixed frequency. Here the variable AC power is obtained by controlling the firing angle of semiconducting devices. Cycloconverters convert a fixed AC to variable AC at variable frequency. Here the variable AC power at variable frequency is obtained by controlling the firing angle of semiconducting devices. Now we understand that depending upon the power handling capacity, the speed of operation, controllability, the devices are selected for particular power converters. Let us study about semiconductor devices. The semiconductor devices act as switching devices in power electronics converters. It is necessary for the design engineers to have a knowledge about working principle and characteristics of the devices. There are many semiconducting devices from thyristor family to transistor family. The transistor family consists of power BJT, power MOSFET, IGBT and SIT. Thyristor family include SCR, Triad, GTO, SITH and MCT. The power diode is the basic building block of all the semiconducting devices. Now we learn about the differences between power diodes and ordinary diodes. The power diodes have high voltage and current capability compared with ordinary diodes. In order to increase current handling capability, it is constructed in vertical oriented manner. For increasing the voltage blocking capability, it has additional N- drift region. Depending upon the application of biasing given to the respective junction of power conductor devices, it operates in conduction mode and blocking mode. Conduction mode is said to be on state and then blocking mode is said to be off state. On and off are the two distinct states of power semiconductor devices. Based on controllability, power semiconductor devices are classified as uncontrolled devices, fully controlled devices, and semi-controlled devices. Diode is said to be uncontrolled device. Both on and off are controlled by power circuits. In forward bias condition, it conducts, and reverse bias condition, it acts as a open switch. Semi-controllable devices. SCR is said to be semi-controlled device because the gate terminal can be used to switch on the SCR and afterwards the gate loses its control. The switch of SCR cannot be done by gate terminal. It can be controlled by external circuit like power diodes. Fully controlled device. The turn on and turn off states can be controlled by low power signal. Example of fully controlled devices are BJT, MOSFET, IGBT and GTO. In BJT, the base terminal determines whether the device is conducting or not. To keep the transistor in on state, there must be sufficient base current. On removing a base current, it is said to be off state. Similarly, in case of MOSFET, gate source voltage determines whether the device is conducting or not. To keep the MOSFET in on state, there must be sufficient gate source voltage. On removing gate source voltage, MOSFET is said to be off state or open switch. Based on control mode, it is classified as current control devices and voltage control devices. Current control devices, BJT is said to be current control device. To turn on, a current is injected into base terminal. To turn off, a base current is removed from the BJT. Voltage control device, MOSFET is the example of voltage control device. On giving gate source voltage positive, there is a flow of drain current. The device is said to be on state. On removing gate source voltage, the value of gate current is equal to 0. The device is said to be off state. Based on current direction, semiconducting devices are classified as unidirectional devices and bidirectional devices. In case of unidirectional devices, the current flows in any one of the cycle, either positive cycle or negative cycle. Example, SCR. Bidirectional devices, here the current flows in both positive and negative cycle. Example is triad. Triad, two SCRs are connected in anti-parallel. So main characteristic features of devices are small leakage current during off state, low voltage drop during on state, faster turn on and turn off characteristic, that is high speed of operation, smaller control power to switch from on state to off state, higher forward current and voltage blocking capability, and a high rate of change of voltage and a high rate of change of current. We studied about one of the power semiconductor devices, power transistors. 4 types of power transistors: bipolar junction transistor, metal oxide semiconductor field effect transistor, insulator gate bipolar transistors, and static induction transistors. In this lecture, we will learn about bipolar junction transistor. Bipolar means the current flows in the devices due to the movement of both holes and electrons. And other features of BJT, it's a 3-layer 2-junction device. Power BJT, it is classified into 2 types: One is PNP transistor, other one is NPN transistors. The three terminals are collector, base and then emitter. NPN transistor is commonly used for switching operation because of its biasing suitable for positive supply with unidirectional current flows. Moreover, the NPN transistors are generally used in common emitter configuration due to the fact that higher mobility of electrons than the holes make the NPN transistor faster than the PNP transistors. The operating modes of BJT, cutoff mode, saturation mode and active modes. Since it is used as a switching element, not as an amplifier, it operates either in saturation region or cutoff region. In cutoff region, the transistor operates as an open switch. To turn off, the base current is removed from the transistors. It means that the junction J1 and J2 are reverse bias. J1 is base emitter junction and then J2 is collector base junction. Both the junctions are reverse bias. Then the transistors operate in cutoff region. It offers a larger resistance to the flow of current. It is equivalent to open switch. During this condition, the supply voltage appears across collector emitter terminal. Closed switch is called as turn on period. During turn on period, a current is injected into base terminal of BJT. In turn on, a conventional current flows from collector to emitter. Here the base, emitter and then collector base junctions are forward biased. The main difference between power transistors and a logic level transistor is that it has additional quasi-saturation region. In the power transistor is to be operated at high switching frequency. The transistor operating quasi-saturation region. It acts as a closed switch when biased in hot saturation. Static characteristics of transistors or volt ampere characteristics of transistors. In transistor with CE configuration, the input base current, output collector to emitter voltage are independent variables, whereas input base emitter voltage and an output collector current are dependent parameter. During off state, device has to operate in cutoff region. During on state, the device has to operate in saturation region. Cutoff region, it is a region in the output characteristics in which the transistor does not conduct. During saturation region, the transistor conduct, there is a flow of maximum amount of collector current and then collector emitter voltage is minimum. The primary breakdown voltage of BJT is similar to avalanche breakdown. It occurs during reverse bias condition. When collector to emitter voltage increase, there is an increase of electron hole pair. It causes breakdown. This type of breakdown is called as primary breakdown voltage. But during on period of transistor, there is an increase in collector current and there will be a decrease in collector to emitter voltage. If the increase in collector current happens uniformly over the entire region on the semiconductor, then the operation of the transistor will be normal. The device current is non-uniform over the entire section of the device, then there is a possibility of secondary breakdown voltage. The main reason for secondary breakdown voltage is non-uniform current distribution, which lead to non-uniform power dissipations. The non-uniform heating of the devices causes the device gets damaged. So main drawback of BJT is it has the problem of secondary breakdown voltage. In case of BJT, both secondary breakdown and then primary breakdown leads to the catastrophic failures. So in static characteristics of transistors, the base current is constant by varying base emitter voltage. Thereby we are varying collector current in respect with collector emitter voltage. The expression for hard saturation and quasi-saturation. In case of our transistor, VCE is the collector emitter voltage, VCC is the supply voltage, IC is the collector current, IE is the emitter current, then IB is the base current. The collector current is equal to supply voltage minus voltage across collector emitter junction divided by collector resistance. Base current is equal to collector current divided by current gain. When base current is equal to base saturation current, the transistor operates in quasi-saturation region. The value of collector current is equal to the difference between supply voltage and the collector emitter voltage divided by collector resistance. When the base current is more than base emitter saturation current, the transistor operates in hot saturation region. The value of collector current during this region is equal to supply voltage divided by collector resistance. This shows that the collector current at hot saturation remains substantially constant if the base current is increased. So these are all the following characteristics of power BJT. Transistor is said to be fully controlled device since on and off is controlled by small control signal. It operated in saturation region and a cutoff mode. Transistor is said to be a bipolar device. It possesses negative temperature coefficient or resistivity. The value of collector emitter voltage is less than 1000 and then current is less than 400 amps. It can operate the switching frequency up to 5 kilohertz. It has low current gain and is not popular in new product due to the problem of secondary breakdown voltage. Thank you.